Okay, so I guess the Q&A session and open discussion has already started. So I just want to ask the questions that were found in the chat box to some previous presenters, and then we continue from there. So there was a question to Francisco Chinesta. Francisco, you are there?
Yes, I'm here.
Okay,
I'm here.
so you can also find it in the chat, but I'm gonna read it. There was a question that said, whenever talking about real data, is performance data or design real data?
Is performance data, is data that we are collecting from the real material in the real process.
Okay, and then another one to you, by performance data and destructive historical data, fatigue, deformation, bending, and shearing forces. I'm not sure I understand the question, to be honest, because maybe there is a typo there.
Very probably is if we are using historical data in order to make prognosis or to make diagnosis. In this case, we are using data to learn, this is sure. We are trying to use the data that we are collecting from the treatment of surfaces in order to learn, in order to classify, in order to take decisions. Obviously, we are taking that, but are based on the process, not too much in the performances. This means that for us, the main objective is to have a success in the process, but we are not very concerned with the properties in life. When I speak about properties in life, is about all the things that concerns the fatigue, the cracks, etc. This could be also, but at this moment, when we are speaking about performances, is speaking about the performances of the process itself, not related to the performances of the component in the real life.
Okay. So there aren't any more questions in the chat that have been left unanswered. So we are over with the chat box, and we may go on now with our open discussion. Pablo, you may moderate this session. Thank you.
Okay, great. Thanks, Mirto. Yeah, we are done with the technical presentations, both from the presenters, Sergio, Paolo, and Sebastian, and after from Dominio Partners. And now, yeah, I guess there are some questions, or maybe you can ask directly, or you prefer you can write also on the chat. But yeah, we have some a slot now where presenters are available, some of them, because I know that Sergio at least had to leave. So yeah, we open the floor for the audience to ask some questions. Yeah, Sergio is here with us. Hello. Well, I take advantage, Sergio, to ask you some questions since you are here now, if you are available, regarding data interoperability, because I know that, yeah, interoperability from a systemic level there are large track record on research there, and with the concept of asset administration shell and how to make machines interoperable. I'm not very expert there, but I know some keywords, let's say. But my question is, what is the difference between those concepts, between machine interoperability and vertical and horizontal integration, and other standards, other data formats from materials, modeling, and characterization that they known as MODA, CHADA, from the European Material Council? I don't know if they are the same thing, or did you have some experience there on how to merge? Does it make sense to merge both concepts, interoperability between machines and between data modeling and or materials modeling characterization? I don't know if you can comment something from there.
Yes, thank you for the question. So I believe we should we should separate the payload from the infrastructure. So what I was talking in my speech was about the infrastructure without touching the payload. So how to create a data space, how to create an industrial data platform which is able to transfer data and exchange data, and how to define the rights, the access rights, and the usage rights of the different actors in the network. These are the, the design principles of data spaces. Then, this is irrespective of the payload. So irrespective of which data you are exchanging in the. However, in real application, this infrastructural model is not enough, as you said, because we need standards, we need data formats, we need the payload to be defined among the participants of an ecosystem. And I've seen here today several data which are originated, and as far as I have understood, the point is still open how to share those data with other partners, with other suppliers, with the end users, and especially which conditions to put regarding the access to the data and the use of the data in order to respect privacy, confidentiality, and data sovereignty of the data. Regarding the payload, we have quite a different story between the three main scenarios, that is the production, the product, and the supply chain. And historically, there has been several developments regarding the payload. And for production, you said that the RAMI Asset Administration Shell is one of the standards in order, for instance, to develop interoperable digital twins of a plant. Which means that if I have to change the production in several production lines, in several production plants, then I could have a simulation of these new productions on the basis of common digital twins model, which could be based on the RAMI Asset Administration Shell, and that's okay. At the moment, this is quite separated from the materials modeling, as you mentioned, and the product modeling. So there is a substantial gap between these two environments. One of the speakers mentioned the process material interoperability, which is definitely one step in the direction to allow an interoperability between the production world and the product and material world. This could be subject of interesting observations, for instance, in Horizon Europe. You know, there is Cluster 4. Cluster 4 in Horizon Europe, which is about industry. It is different from transport, which I don't remember which cluster is. But in Cluster 4, we are addressing exactly this interrelationship. Another thing is the supply chain, and specifically scenarios which could concern manufacturing as a service, including additive manufacturing as a service. So I have an order, and I don't know who is able to satisfy this order, and I launch this order in an ecosystem of companies which are able to perform just a part of this order, and then you obtain the answer from an ecosystem of peers which are connected in order to satisfy this order. This is quite common in some local networks, like the smart a CSN, for instance, in the South Netherlands, the smart supply chain network, where several high-tech companies have formed this association in order to implement a manufacturing as a service business model. As I mentioned before, there are some research experiments regarding additive manufacturing. That is to see which is the best station, which is the best additive manufacturing printer or machines which could meet my requirements. And this is something that it is also important, but the three domains are currently quite separated. That is the domain of the production, of the product, and of the supply chain. So we need really some cases where to unify them.
Mm-hmm. Okay, that's clear. Thanks, Sergio. Mm-hmm. Mm-hmm. I have also some questions for Sebastian. I don't know if Sebastian is here with us already.
Hey, I'm here.
Hi. So Sebastian, you were talking about that you're working with AFP plus infusion in vacuum bag. In Dominio, we are interested in analyzing defects generation online. And I guess that AFP plus infusion has also the problem of propagation of defects. Several gaps, overlaps, for example, or bubble during AFP, and how they affect during infusion. So I guess that this is like a second round, I mean, even more complex problem, to identify defects during AFP and analyze them and predict their effect during infusion, take the decision in real time whether if it's better to fix the AFP problem before you go to the infusion or not. I don't know if you have tackled this or this is a little bit far away. I mean, does it make sense to really study simulation-based the propagation of defects from AFP to infusion?
Yeah, so that's a good one. I think it's still pretty far away from us. So for us, combination of AFP with vacuum and consolidation is more what is the effect of say gaps on the void migration. We are still more on the level of making idealized laminates and see how we can consolidate good quality laminates from AFP stacks, so to say. Okay. And then it's really depending on the tape that you use, how the AFP process works. So there's a difference between tapes coming from supplier A, say Solvay, and supplier like Toray or Teijin or Supreme. So the response of the AFP process to the material is different, and then consolidation under vacuum is a different topic, and it's not certain. So some materials work better in the AFP than the other, but it doesn't mean that they also work better in a vacuum consolidation process. So there's different things in the morphology of a tape that determine processability either in the AFP or under the vacuum bag. And it's finding the right combination and the right recipes that will eventually lead to acceptable product. And this is only, say, in our case, trying to understand this for flat laminates, maybe with ply drops. So how do we fill the pockets that arise when you drop plies? So we're kind of come very far in that sense. And the next step would be to go to double curvature, where you have the gaps and overlaps and all the things that can happen during production due to unforeseen circumstances, splices in the tape, change of humidity, temperature in your production environment, variability of the tape. I heard roughness of the tape being a variable. That's the roughness that you can measure on the tape as received, where we think that the roughness of the tape before it enters the nip point, so or the roller, so the roughness may change as soon as you deconsolidate the tape in the AFP head. Can also be very important. Same with reflectivity of the tape. So as soon as the tape starts to melt, the reflectivity of the tape changes, and that's different for different tape suppliers.
Mm.
So yes, still quite a lot going on there.
Mm. Mm. Interesting. Mm-hmm. Yeah, in terms of quality control of the in situ consolidation, we are very focused on air couplet ultrasound system, very low TRL approach actually. We're also considering the possibility of measuring cool down rates to somehow infer the crystallization degree somehow. I don't know if under your experience you see other interesting options as well to integrate it in the AFP process. Mm-hmm.
Yeah, I think if any sensor that you can implement would be very welcome. Although it's it's very difficult to measure the relevant stuff and where the magic is happening. So under the roller or just after the roller. So we are kind of working on a combination of physics-based modeling and finding the right sensor. At the moment, for us, it's temperature.
Mm-hmm.
At least at the nip point to get that accurate. Things happening after the roller in terms of cooling, that probably we would go for something offline, then calibrate the models and see if that works.
Mm-hmm. Yeah. Mm-hmm. Yeah. Mm-hmm.
So I'm really interested in your approach. We did not yet consider NDI during processing.
Mm-hmm. Yeah, and well, I don't know if there is a question from the audience. I have another one also for you, Sebastian. Regarding the combination AFP and FFF, it was presented by Francisco that we were going to produce skins with AFP and then several operations for FFF, for stiffers, for sensors, for nanomagnetic magnetic nanoparticles for disassembly. So I mean, so the question would be in terms of productivity indicators. AFP, we are working with small heads with large flexibility, but at the same time low dimensional tape. So how do you see the AFP in terms of productivity on the speed that it can go, or the area to be covered? We are now probably the bottleneck would be laser heating. At least this is my feeling. I'm not the expert, but my concern is, okay, how to really identify the selling point for productivity in these kind of technologies.
Yeah, so you can pump in quite a lot of energy with a laser, but in the end, it's the physics that determine the time. So in the end, I mean, we can drop plies very fast, 1 meter, 2 meters per second, I think, with modern machines. But then you spend a very, very short time under the roller. And then you're reaching really the limits of the polymer healing. So you can create a bond, but the interlaminar strength will be relatively poor. So in that sense, I think the polymer physics will kind of limit the productivity there.
Yeah.
And then it's if you can keep the same speed but drop 8 toes or I don't know 24, 48, then that would be the way to increase the productivity.
Yeah, yeah, definitely. Yeah, if one can imagine, at least in the future, since we are combining AFP and FFF, not simultaneously, of course, in our project, but then you can think on a large cell with moving robots with different AFP heads simultaneously laying a surface. So it's a way of increasing. But yeah, I mean, of course, there is I guess, a limitation of the physics of the polymer. You need to give it time, resident time, something like this, to make the cross-linking happen between the both tapes. But I think, well, on the other hand, Pablo from Caracol mentioned that they are working on atmosphere or controlled atmosphere cells. I guess in terms of composition of or humidity and these kind of things, but maybe you can also be intermeter somehow. So I mean, preheating of the substrate is also accelerating the process itself. So maybe it's another way.
And the question with the FFF, do you need a post consolidation step for the filament? So you to get rid of entrapped air?
I don't
in situ.
Consolidation. Francisco, you can answer this one. You with us,
yes.
Fran?
For the moment, is something that we are working on. It has to be assessed. Is probably that post-consolidation cycles will make better some properties, but we also have here the dimension stability issue that could be affected by a post-consolidation process.
Mm-hmm.
So it's a trade-off. I think it's something that we have to assess. It depends on the geometry of the piece, of the part, if we can apply vacuum, if it's going to be different in each part. I think it's an interesting topic, but that has a lot of property possibilities and different scenarios.
Yeah. Okay.
Yeah.
I don't know if Paolo from Caracol is still with us.
I believe that he left some minutes ago.
He seems to be.
No, I think he's here.
But I don't know.
Paolo?
He's here.
I heard the question.
Your name?
Yes, I have a few minutes, but of course I can.
Okay.
I can.
Yeah, just a quick question for you, Paolo. I'm wondering if you, because I saw some good solutions out in the research projects for additive manufacturing based on I would say is numeric control machines with gantries producing very nice products. And how this, I mean, what is the advantage of having a higher degree of freedom solutions such as robotized arm and so on? Because I guess that you are losing somehow accuracy, but at the same time you increase freedom for operation. So have you considered also gantries for your company?
Well, this is a very good question in terms of let's say our competitors, let's call in this way, are using this kind of solution of approach. So using a very big gantry to produce on a big scale additive manufacturing pieces for nautics, for aerospace, and so on. And well, we decided to go years ago on robots because first of all, basically the weight of the whole system, it's really less than a very big gantry. So it's a larger machine, a larger cell, and a robotic cell is really easier to install. The cost is less than a very big gantry, and so this is one of the big differences. And when we are talking about this kind of 3D printing also, so big scale 3D printing, when you actually drop the material, you're not caring too much about the precision, because any case you will have to mill a little bit the surface in order to match the requirements of the clients when you do this kind of jobs. So for example, jigs for aerospace, or any case pieces, molds for autoclave and so on, you have to pass through the milling process. So basically you make in a very smarter way the first piece, and you just mill 1-2 millimeters on the surface. So also the milling part is a lot less than mill from the block, of course. So the cost of the time is a lot less, and it makes sense to do things in this way. And what we can do and what gantry cannot do is, for example, gantry actually are made to do just huge parts. So they have actually a restricted area of application. With our robots, we can do stuff from 1 skew meter to 10 skew meter, and with the same precision. So we are we are able to serve more application in this kind of fields, and not just the huge ones. Okay. And another thing is as you were saying, the flexibility and the freedom of movement helps you, for example, to print on existing surfaces. That is something that with a country is pretty. It's more difficult to do. You can do it, but it's not the best solution. Of course, is the robot, and you can print in 45 degrees. You can actually use all the axes to make also not planar slicing, for example, and this with a high control of the flow and of the deposition of the material. It makes you able to make in one piece very complicated and strange pieces that with a gantry you cannot do. So these are the main differences between these two approach on large scale 3D printing. And maybe in the future we will put a robot on a gantry so to mix this. Right now we are using the rails, as I was saying, to increase the volume and not a gantry system. And we will see in the future. We are also talking with some of these companies, and this is
okay. Okay, and this extractive stage, are you carrying this out on the same robotic arm or in the different one?
Sorry?
The polishing, the post-processing step that you mentioned, are you carrying this out on the same robot or in another one?
Well, you can do it with the same robots.
Yeah.
So having one cell that is actually 3D printing and milling. So this was our first output of our system, and of course you can take in put in parallel two cells that is doing, one is printing, the other one is milling. So if you need to actually activate the production, this is more efficient. But it's the flexibility of the robots makes you able to make also tool changing and with no such complex complexity. So you actually can do it, and we do the. We are not doing this in intern, so we have one cell that is milling and one cell that is not one, and cells that are printing, and we are gonna study also the tool changing. But what we are seeing is that companies are at first step attracted by one cell that does everything.
Yeah.
But when they have actually to face the production and the timing, we decide with them to actually split the cluster into elements, let's say, to robotic cells, and go with this.
Okay, thanks.
Thank you.
Is there any other question in the audience? I don't know, Mirto, are we going to locate the presentation somewhere in our web page, in the media web page, the presentations and or the video, or how?
Yes.
Mm-hmm.
We were recording the whole event today, so well, we will upload it, and
I guess we will prepare a sort of video from this material, and also the presentations, since we have the approval from the presenters, will be uploaded also on the website.
yes. I saw a raised hand by Ricardo, or was it?
Yeah, I was trying to do it, but
Okay, I saw
I
that.
don't know if I succeed or not, because I was having issues with the hand during the whole meeting. But
well.
now I did it on purpose.
Okay, really?
Yeah.
So
So
there is no question, just checking the raised hand.
no, now I have a question, but
Okay.
it happened before during the presentation, but I don't know why. But
Oh, I'm sorry
yes,
about
now I
this.
have a
You
question.
should have chatted. Well, okay, good.
It's for Pablo from Caracol. Not sure if he's still here.
I'm here.
Yes, it's about it's also about the post processing, but after, because you mentioned when you did your presentation that you were controlling a lot of things, so the temperature of the bed and so on. And my question is, after making the part, do you do any post processing in terms of put the part in an oven or something?
Yes, we do.
You do.
For let's say, depends on the material we're using.
Yeah, sure.
So of course, talking about, for example, polyamide, we do the thermical process afterward, and yeah, we do it, and we do not do this internally right now. Maybe in the next year we will also provide ovens internally to print, or maybe we will have a sort of production cell that actually is a oven, and we do the thermical post-processing while we are printing, so like some kind of 3D printers does, and we will see. But definitely we do this kind of post-production processes afterward the printing.
Thanks.
Just curious about the behavior of the polymer when you do the machining. Is it at room temperature, or do you have to how does it behave? I mean,
well, what we actually experimented from reality, because also our first partners in milling that mills everything, and they are huge companies with hundreds of milling machines, they actually didn't have any kind of experience with plastics. and especially, of course, with 3D printing plastic on this scale. So after the 3D printing production, the post-production, the thermical post-production, we didn't recognize any big movements or differences between the pieces from the production to the post-production. And also when we were milling, the pieces were not so stressed. We didn't have cracks or whatever. And so actually we experimented a pretty good behavior of the pieces. So
Yeah.
is actually something that is doable, and that if you 3D print in the correct way, you do the post-process. Actually, I think that also for some kind of pieces, probably also without the thermical post-process, it could work any case. So the stress of the material is released most of all during the printing. So if you are able to control the thermical aspects of the environment of the layer while you are printing, you actually absorb or release the mechanical stress on the during the printing, and then you have just to when you work it after that, there's no stress inside, so you can actually do it. And we are talking about the position and like wall thickness of about from 5 to 10 millimeters, so it's a lot of material. And maybe if on one hand we have, for example, a lot of shrinking because of course of this deposition, on the other hand, when the layer actually is glued together, it remains like that. So even with maybe temperature shocks or stuff like that, we didn't experimenting anything like this as far.
Very interesting. Okay. Well, from my side, I don't have any other questions, so I don't know if we are 5 to 2 o'clock. Let the audience to have the last chance to have a question, otherwise I think we can close the workshop. Mirta, what do you think?
Yes, I don't see any more questions, to be honest. So I think it was a fruitful, open discussion, and in general, really nice presentations here today. So thank you all for being here. And well, see you in the next Dominio workshop. And well, thank you.
Okay, thank you very much to all presenters. Thanks a lot for your time.
Thank you.
Thank you. Thank you
working.
for the participation. Bye.
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 Thank you very much.